This is AP Calculus 6-2, Part 3, approximating the area under the curve using the midpoint Riemann sum. And first I'm going to give you a couple pictures to show you what the midpoint rule is. We looked at these when we were doing left and right Riemann sums, and they're very similar. If you look at this picture, that is a left Riemann sum. The rectangles are drawn from the left. The left-hand corner of the rectangle is the one that's touching the f of x function. This side is your right Riemann sum. It's touching the f of x function on the right side of the rectangle and being drawn. And you can see that this one would be an overestimate. This one would be an underestimate because this one accounts for more than what is actually in the function itself, and this one accounts for less than what is actually in the function itself. The midpoint rule is kind of in between those two. Instead of drawing from the left or from the right, we're going to find the midpoint between our intervals. It looks like this one is separated into 10 different intervals. If you look across, you can see 10 different rectangles for each of these. And let's just say that this is going from 0 to 10, and so these are in 1 unit increments. If that's the case, to draw our midpoint Riemann sums, we're going to find the halfway point for each interval. So if this interval goes from 0 to 1, the halfway mark would be at 1/2. So I'm going to draw a dot on my function at 1/2, and then I'm going to draw the rectangle to the left and right of that midpoint and down to where the interval ends. Let's say the second interval is from 1 to 2. The halfway mark would be at 3/2 or 1.5. That's where I'm going to draw my point on the function, and I'm going to draw my rectangle so that it's midpoint way across the top of that rectangle and then down to the next one. And so when you're talking about the midpoint rule, each of these rectangles is going to have a portion that's being left out and a portion that is extra. Portion that is left out, a portion that is extra. The idea is that the portion that is left out and the portion that is extra are about the same, and they would cancel each other out. And the answer that you get for the midpoint rule is going to be somewhere in between the left Riemann sum and the right Riemann sum. And it's kind of common sense. You can kind of see that that's what's happening here. Here's another example of the midpoint. This is the left Riemann sum, right Riemann sum, and here is the midpoint, where we're going halfway between the left and right edges of each interval to draw our midpoint rectangles. And the process is still the same. The width of each of these is going to be equal. The heights are going to be found by finding the midpoint between each interval and plugging it into your f of x function. Then we'll find the area of the rectangles and add those areas together to get an estimate for the total area under the curve. So we're going to do this same example that we did in the first part of this section with left and right hand Riemann sums. We're going to estimate the area bounded by the curve and the x-axis on the given interval using the indicated number of subintervals by finding, we already found the left Riemann sum and the right Riemann sum. In this section, we're going to find the midpoint Riemann sum. So I'm going to go to the whiteboard and do this one for you. And you can put that in your notes. In this one, we're going to do the midpoint rule for the y equals square root of x. This is the same example we did yesterday. Y equals square root of x on the interval 0 to 1 with 4 subintervals. And we've learned that when we're doing the midpoint rule, we're going to draw our heights for our rectangles just like we did yesterday when we were doing left Riemann sums and right Riemann sums. But when we're doing the midpoint rule, we need to find the halfway point between each of these intervals. So I'm going to use this one right here would be 1/8. And at 1/8, I'm going to draw a point on my graph that would be representing the height at 1/8. I'm going to go halfway between 1/4 and 1/2, which would be at 3/8, and do the same thing. So at the halfway point between each of these, I'm going to draw a dot on my graph for y, or this is y equals square root of x. Halfway between 1/2 and 3/4 would be 5/8. So at the 5/8 mark, I'm going to draw a dot, and then halfway between 3/4 and 1 would be at 7/8, so that would be about right there. And then I'm going to draw rectangles using those midpoints. So my rectangle height for this one is going to be right there. That's my midpoint rectangle. This rectangle is going to be drawn here. The third rectangle is about right there. And the fourth rectangle is about there. And so you can see here that if this rectangle is drawn here, we've got this portion of extra that we're finding the area for, but this portion that is left out. And the idea is that these two portions are going to be pretty close to each other and kind of cancel each other out. So you're getting something even more accurate than the left Riemann sum or the right Riemann sum would have given you. Here, this little extra and this little bit that we're not accounting for are about the same. Here, this little bit of extra and this little bit that we're not accounting for are close to the same. And this one, if you see how that kind of levels off, looks very close to what the actual area under that rectangle would be. So you can see here with the midpoint rule, we're going to get something even closer to the actual area under the curve. So what I'm going to do, my width for all of these rectangles, remember, is still 1/4. But now the heights are going to be what we have when we plug that midpoint in. So what do I get when I plug in 1/8? Here, what do I get when I plug in 3/8? For this one, what do I get when I plug in 5/8? And for this one, what do I get when I plug in 7/8? So for the first rectangle, my width is 1/4, and my height when I plug in 1/8 is 1/2 square root of 2. My width for the second rectangle is 1/4. My height when I plug in 3/8 is the square root of 3/2 square root of 2. For the third one, my width again is 1/4. My height is what I get when I plug in 5/8, which would be the square root of 5/2 square root of 2. And for the last one, I would have 1/4. What do I get when I plug in 7/8? I have the square root of 7/2 square root of 2. At this point then, I can plug that into my calculator and get the decimal equivalent of that and estimate I always do 3 decimal places. That's usually what they're going to ask you to do on the AP test. Another thing I could recognize when I'm dealing with the midpoint rule is, what do you notice? And you may have noticed this when we were doing the rectangles as well. Aren't all of these widths the same? So couldn't I say, if I wanted to simplify this, that is 1/4 times 1/2 square root of 2 plus square root of 3/2 square root of 2 plus square root of 5/2 square root of 2 plus square root of 7/2 square root of 2. And then wouldn't that simplify my math a bit? My denominators are all the same. That's 2 square root of 2. My numerator is 1 plus square root of 3 plus square root of 5 plus square root of 7. And that might be a little bit easier to plug into my calculator rather than putting all of this in. And when I plug that in my calculator, I get 0.673 as my decimal equivalent for the area underneath that curve. And if you look at your notes, when we did this for the left Riemann sum and the right Riemann sum, this should be somewhere between what those two sums were. This is the same example that we began in the last section as well. We've already done the left Riemann sum and the right Riemann sum. Today we're going to do the midpoint Riemann sum. So I'm going to take this and draw my midpoint Riemann sum and figure out the area of each of the rectangles that I end up with. So the first thing I'm going to do is draw a dot halfway between each end of the interval. So I'm going to say this is about the midpoint between 1 and 2. This is about the midpoint between 2 and 3, here between 3 and 4, here between 4 and 5, and here between 5 and 6. Then I'm going to draw straight across the top of where each of my rectangles will be. And you can see as I draw these that part of your rectangle will be inside the curve, part of it will be extra. Okay, so here are my rectangles drawn at the midpoint halfway between each of the intervals. And so if I'm going to figure out the area under the curve here, Well, still, the width of each of these is still the same. The width of each rectangle here is still going to be 1. That hasn't changed. So the width is going to be 1. And then the height is going to be from the bottom of the graph up until where the midpoint touches the f of x function. So if I just look here, it looks like this length, I'm going to say, is about 2.5. So for the first rectangle, we've got 1 times 2.5, or 5/2. Plus, for the second rectangle, it looks like this height is about 3.5. So I've got 1 times 3.5. For the next one, it looks like the height is about 3.5 again. So we've got 1 times 3.5, the width times the length. Here it looks like it's 1 times 2.5 again. I'm going to move down here. And then for the last one, it looks like 1 times about 1.5. And so if I multiply all those together, I'm going to have, and I'm just going to convert them to improper fractions. So I've got 1 times 2.5 is 5/2, plus 3.5 times 1 is 7/2. So I've got that twice. 2.5 times 1 is 5/2, and 1.5 times 1 is 3/2. So if I add those together, I've got 12 plus 7 is 19, plus 5 is 24, plus 3 is 27 over 2, which is the same thing as 13.5 if you like it as mixed numbers. It really doesn't matter which way you express it. But the area under the curve here is 13.5. And you could look back to your notes in the last section and see that 13.5 is between what the left Riemann sum and the right Riemann sum would have been. So for this one, we have already done A through C. In this section, we're going to do D, estimate the number of gallons of oil that have leaked out of the tank during the 12-hour period, and find the midpoint Riemann sum with 3 equal subintervals. So for the midpoint Riemann sum here, I'm just going to take this and make it a little bit bigger on the next screen, and we're only going to concentrate on part D, the midpoint Riemann sum. They're asking us to do it, they said, into 3 subintervals. So what I'm going to do, if I'm going into 3 subintervals, the width is going to go from 0 to 4, and I'm using 2 as my midpoint. So if I draw that, here is my first rectangle, my second rectangle, and my third rectangle. So if I'm looking at that, the width of each of these rectangles is going to be 4, and then the height is what I would get at the midpoint between each of those. So the width for this rectangle is 4, and it's multiplied by our height at 2. Well, the height at 2 is 38. Here the width again is 4. We're looking for the height at the midpoint, which would be 6. At 6, we're at 30. And then the last rectangle has a width of 4, and the height at the midpoint of 10 would be 18. So I'm going to use my calculator to do that math. 4 times 38 is 152. 4 times 30 is 120. That's a plus. And then 4 times 18 is 72. And if I add those together, I get 344. And remember, for our unit, gallons per hour times hours, which would be gallons. So 344 gallons have leaked out of the tank over the 12-hour period.